this video, we're going to talk about constraints. Pardon my voice, I'm a little sick right now. So I'm going to go to Create Polygon Primitives, and I'm going to make a sphere, and I'm going to make a cube. Now let's take the cube and let's move it over, and let's freeze its transforms. Okay. So now we're going to mess around with constraints. When I have geometry, I'll often click on this button here so I can see the geometry, see what's going on, so I can see the edges anyway. So constraints, they're found in the rigging menu, and they're under constrain. And so again, we can tear off that menu if we want. We can just leave it hanging around. Or we can just put it up on our shelf. So I have this rig for game shelf. So I'm just going to go ahead and add parent, point, and orient. Click on the option box, we'll bring up the dialog box. Okay, so a parent constraint. Now, if I were going to parent the cube to the sphere, what I would do is select the cube first, shift select the sphere, and type P. So then if I were to rotate the sphere, the cube would go along for the ride. But again though, if I select the cube, it's still frozen. It's maintaining this relationship that it had with the sphere from the get-go. So if I drag down, hit 0, reset the sphere, or I could just go to reset transforms. That's going to put everything back at 0. When I resetted the transforms, that also reset that on the cube. So I'm going to go back here to the cube and say center pivot. But you notice it doesn't change, whether the pivot's here or over here. Either way, it's zeroed out. Okay, so to unparent the cube from the sphere, let's just Shift P. So now we're going to constrain the cube to the sphere. So now what you do, when you constrain, you kind of pick the opposite way. So here I'm going to select the sphere first, shift select the cube, and I'm going to come in and I'm going to click on reset the settings here, and I'm going to parent constrain the cube to the sphere. I'm going to leave on maintain offset. Let's click apply. Close. So once I've parented something, you can see that the thing that has been parented, something else is parent constrained rather. So you can see that something else is acting on it because it's magenta. If you select the cube, you can see these blue sort of markers on the channels. So that means that it's constrained to something. So we're going to get pretty much the exact same results if we rotate around. But since this is parent constrained, you can see that it's now got these values on it because it's constrained to that. Okay, so if we wanted to, so the cube, if we expand the hierarchy here, you can see the parent constraint on the cube. So if I wanted to delete the constraint, I could just come here to the cube where we see that constraint. This is parent constraint, and I can just delete it. And then if I reset the transforms. It's going to go back where it was. And same thing there to make them 0. Or if I hit Z and undo, I could then take this and freeze the transforms. So that's now at 0 point. And I could freeze the transforms here too. So again, I can't overstate the importance of knowing about your transforms when they're in relationships so that your rig works correctly. So here I'm going to look at constraints without the offset. So I'm going to go to point, and if we go to edit, reset settings, maintain offset is unchecked by default. Okay, so I can select the first element and then select the second and constrain the second to the first. So let's apply. And so now we can see that this cube inherited or is constrained to the first cube and inherited its translation values. Now if we wanted to rotate it or orient constrain it, same thing. Select the first one and then the second and take off maintain offset there and apply. And so now the second cube has inherited all the values of the first, with the exception of the scale, because I scaled the other one a little bigger just so you could separate the two. And again, you could just do this on a per axis basis. If you only wanted to constrain certain axes. Now you can also add a weight to your constraints. So let's take 2 cubes, and since I'm messing with cubes and spheres so much, I'm going to add a cube and a sphere here to my shelf. Okay, so I'll take this cube and move it over. Let's make another one. And let's move that over. And let's drop in a sphere. Now you can also, items can be constrained to more than one element. Okay, so for instance, what I'm going to do is take the sphere and I'm going to constrain it to be, actually I'm going to scale this down a little bit. These transforms. So I'm going to take the cube and then the sphere, and let's do a point and orient constraint. Let's put the weight at 0.5. Apply. So I'm going to take the right cube and the sphere, and I'm going to do a point constraint. Let's maintain the offset again. Let's click on apply. Let's also do it for orient. And the selection order still is the same. Apply. And I'll do the same thing this cube. Apply. And apply. So if we look at the sphere, over here in the channel box, we can see that it's got constraints on it, the light blue. And we can see that it's got a weight of 1 here in its constraint under the shapes. We can see that the point constraint has 2 weights on it with cube 1 and cube 2, and the orient constraint has 2 weights on it with cube 1 and cube 2. So if we take the first cube and we rotate it, we can see that the cube is rotating half the distance or half the amount in y as this one. And then if we took this cube and rotated that the other way, the sphere is going to inherit, it's going to be constrained to both of them. So it's going to inherit both of them 50%, but we can come back here and we can change this to 0.5 for each one. That's on the orient. We can click on the point. We can do 0.5 for each one. So if we move this up, it's going to be somewhere in the middle. And if we rotate, also the rotation is going to be somewhere in the middle. So let's rotate this one just 30 degrees in Y. So this should be 15. And if we rotate this one let's do a negative 30 degrees. Now this is at 0 because it's taking the splitting the difference between the two. Now we could come in and we could change this weighting. So maybe this is 0.25 and this is 0.75. Do the same thing on the point constraint. And so the sphere is going to favor this cube. Now another cool thing about these constraints is they can be animated. So for instance, let's make a 30 frame animation here. And at frame 1, I'm gonna put the weight completely, actually no, I'm gonna just leave it where it's at. So let's select these and right click, key selected. Let's go to the points, key selected. So at frame 1, these are keyed. And at frame 10, I'm going to change all the weight to cube 1. So 0 and 1. Do the same thing on the orients. 0 and 1. And then at frame, let's go to frame 20 and just swap those out. 1 and 0. 1 and 0. So it's a 20 frame animation. Okay, so we start. It's the constraints are weighted to both. Then frame 10 weighted to the first cube, frame 20 to the second cube. So constraints are very powerful, all right? And so I just wanted to show you the things that you could do with them. And you might be asking yourself, well, why use a point or an orient? Why not just always use parent? Well, sometimes you can sometimes you don't need to use parent. Sometimes it's just more convenient to use the point or the orient. And so a lot of times it's preference, and there's other times where you just want to be a little more specific.